Part B?
Okay, I think I know why I got it wrong then, because I saw the plus sign as divide, so I didn't get a.
Oh, no. This may, I mean, it's a little bit messy here. This is just 2 pi times n minus 76 divided by 365 plus 11.43. Huh? Very loud. Shanghai boy, probably. Oh, just kidding.
Second, I think it's
Who is from Shanghai? No.
we have Shenzhen.
Ah, really? Shanghai boy. Hello. Okay, everyone. Do you have any question about this assignment or the previous assignments? No question? Okay, so let me continue our discussion of combinations of functions or composition, basically. So did you finish this exercise? Everyone? Okay. Let me do it. I can maybe one part. So first, let me compute f inverse. So this is f of x. Remember that y equal to f inverse of x means x equal to f of y. So x equal to 3y minus 5 divided by 2 minus y. That means 2x minus xy equal to 3y minus 5. So that means 3y plus xy equal to 2x plus 5. y plus xy is, that's right, 2x plus 5. So y is equal to 2x plus 5 divided by x plus 3. Is that right? Is that the inverse you got? 2x plus 5 divided by x plus 3. Okay. 3 plus x or x plus 3 are the same. So you have f of x, 3x minus 5 divided by 2 minus x. This is f of x, 3x minus 5 divided by 2 minus x. And f inverse of x equal to 2x plus 5 divided by x plus 3. Okay, that is f and f inverse. Now I want to show that when you compose f with f inverse, so let's do, for example, f o f inverse. You must get x. Let's see. So what is f o f inverse of x? F inverse? Okay. Let's do f inverse o f. So f inverse o f is f inverse of f of x. So this is f inverse of, what is f of x? F of x is 3x minus 5 divided by 2 minus x. Now you have f inverse of this. That means this must be 2 times 3x minus 5 divided by 2 minus x plus 5 divided by x plus 3, which is 3x minus 5 divided by 2 minus x plus 3. So you have two fractions on the top. So this equal to, on the top you have, let me write all terms. You have 6x minus 10 plus 10 minus 5x divided by 2 minus x. That is the denominator. Sorry, the numerator. The denominator is 3x minus 5 plus 6 minus 3x over 2 minus x. So the 2 minus x cancel out each other. So on the top you have 6x minus 10 plus 10 minus 5x, which is x. So you get x on the top divided by, and then you have 3x minus 5 plus 6 minus 3x, which is over 1. That is x. Magic. So f inverse of f is just x. And it must be. I mean, this is. Okay, so now let me explain about the domain of compositions of functions. So we want to find, so how to find the domain of FOG of x. So here is the general definition for the domain of FOG. The domain of FOG is equal to, first of all, you must have x in the domain of G, because you first apply G, so that means x must be in the domain of G. So here you have two conditions. X must be on the domain of G. The second condition, this is the first condition. The second condition is that G of x must be in the domain of F. So this is the second condition. So to find the domain of FOG, you have to check two conditions. One, x must be in the domain of G. Second, G of x must be in the domain of F. I will explain, don't worry, it's not something strange. It would be clear if I give you some examples. For example, imagine that f of x equal to 1 over x minus 1 and g of x is, for example, e to the power x. So one way to find the domain is to use those two conditions. Here, the domain of G is just the first condition is X must be in the domain of G, which is R, right? So there is no restriction for G. But how about F? What is the domain of F? The domain of F is everything but 1. So the second condition tells you G of X must be in the domain of F. So that means G of X cannot be equal to 1. Because the domain of F is everything but 1. So that means E of X, what is G? G of X is e to the power x. So e to the power x cannot be equal to 1. Therefore, x cannot be equal to 0. Okay, so the first condition basically doesn't give you any restriction, but the second condition gives you just one restriction. X is not 0. So that in total, the domain of FOG is, in this example, is all numbers except 0. So here, R minus 0 means you remove 0 from real numbers. Or you can say all real numbers that x is not 0. This is equivalent. No, that's the domain of F. So G of X must satisfy the restriction for F. So G of X cannot be 1, not X, okay? And the other way, I mean, maybe a better way to see this is just to write the equation for FOG. So remember that f of x is 1 over x minus 1, right? And g of x is e to the power x. So FOG of x is just f of g of x, which is equal to 1 over e to the power x minus 1. Well, maybe I write another step. This is f of e to the power x, which is 1 over e to the power x minus 1. So once you write FOG, then you can see clearly from this equation that the only restriction on FOG function is that e of x cannot be 1. That means x cannot be 0. So another example. Let's say that f of x is square root of x and g of x is cosine x. Again, there are two ways. Either you can say f or g of x is just f of g of x, which is just a square root of because once we have FOG, then we can easily find the domain. So here, the only restriction is that the cosine must be positive, right? First of all, there is no restriction of g of x, which is cosine. There's no restriction on cosine. But the only thing is cosine must satisfy the restriction for f, which is a square root. So that means cosine. So the only restriction that we have here is cosine must be greater than or equal to 0. Now, can you tell me on what intervals cosine is greater than 0? On what interval cosine is greater than 0? Let me draw cosine just quickly. Just a sketch of cosine x. So on what interval cosine is greater than 0? So x can be between minus pi half to pi half, or 3 pi half to 5 pi half, or 7 pi half to 9 pi half, and so on. You see, on these intervals, cosine is positive. So that means x must be in these intervals, minus pi half, union with maybe I just write another. And then there are infinitely many of them, of course. Any question? Okay. Now, can you compute another example? This is an exercise. Imagine that f of x equal to So can you compute here the domain of FOG? What is the domain of FOG? Remember that you have to check two conditions. One is X must be in the domain of G. So these are the two restrictions, basically. X must be in the domain of G. Second of all, G of X must be in the domain of F. So what is the domain of F here? Domain of F is numbers greater than 1. So you have to check two conditions. One is X in the domain of G. That means basically X cannot be 1, right? Because the domain of G is all numbers except 1. So it's all real numbers except 1. So here, this minus sign means you remove 1 from the real numbers, which is basically the same as X in R. So you have to check this condition. X is domain of G, but G in domain of F. So the second condition, you have to work on it. So what it follows from the second condition? What restriction on X you get from the second condition? Can you do it? So G of X, basically it means G of X must be, the second condition means G of X must be greater than or equal to 1. Because the domain of F are all numbers greater than or equal to 1.
What's the point for the domain of G if we're just looking at
Now, the domain of G is the first condition because first G applies. So you have F of G of X. So first G acts on X. So X must be in the domain of G.
But when writing F of G, we're just writing the domain, the thing for the F, right?
Yeah, but as I said, you first apply G.
Yeah, but every time we write it, you didn't include.
Because sometimes the G, they have no restriction. For example, in these two examples, there are no restrictions on G. But here, there is some restriction on G. Actually, there's only one restriction on G, and that is X cannot be 1. So, what did you get? Liana, tell me. G of X greater than 1 means, it basically means 2x plus 1 over 1 minus x must be greater than 1, right? So you have to solve this inequality. 2x plus 1 over 1 minus x must be greater than 1. So That means 2x plus 1 over 1 minus x minus 1 must be greater than 0. So 2x plus 1 minus 1 plus x over 1 minus x must be greater than 0. So you have 3x over 1 minus x must be greater than 0. So 3x over 1 minus x must be 0. So it means that we can basically draw as just a small chart. So this is 3x. 3x is 0 when x is 0. Here is positive, negative, and 1 minus x is 0. And x is 1. But here is negative, here is positive. Therefore, so that means x must be between 0 and 1, right? Here is the solution. So we have two conditions. One was x cannot be 1. The other one is x between 0 and 1. So if you put this together, you have, so the domain of FOG is just numbers between 0 and 1, including 0. So the domain of FOG is all numbers between 0 and 1, but you have to remove 1, right? Was this clear? Any question?
So you're going to do using the second element to find the domain, right?
Yeah, and we have to also be careful about the first condition, that x is in domain. Okay. Okay, so let me begin a new topic, which is rate of change. rate of change. So we basically have two types of rates of change, or rates of change. One is the average rate of change. What is the average rate of change? Imagine that you have a function f of x. And we look at this function in some interval, like x1 and x2. So if you have 2 points like x1 and x2, so let's say that y1 is f of x1 and y2 is f of x2. So the average rate of change from x1 to x2 is, so average rate of change, I just write AROC. This is average rate of change equal to y2 minus y1 divided by x2 minus x1, which is f of x2 minus f of x1 divided by x2 minus x1.
No, not really. That's following, but so it just feels like there's, I don't know, some small resets or whatever, just shoving in my cheese.
So
And it's mostly okay.
example, imagine that f of x is x squared plus 1.
No, not really.
So we want to find the average rate of change in the interval. So find the average
I don't, well, I haven't tasted any blood, so I don't think I can.
rate of change
So I think
in
only one of this. Nothing much.
This interval. So here x1 is 2, x2 is 5. So y1 is f of x1, which is 2 squared plus 1 is 5.
I don't think so.
Y2 is f of x2.
I don't recall that. Mom might have it, but I don't remember her giving it to me.
So what is f of x2? F of 5, which is 5 squared plus 1, which is 26. Right? So the average rate of change is y2 minus y1. So let me write it here. Average rate of change is
Oh, yeah, like I
y2
doubt that.
minus
So
y1.
mom doesn't have feedback that's not gave yet.
So you have on the top 26 minus 5 divided by 5 minus 2, which is 7, right? Is that clear? So basically, for the average rate of change, you have an interval of x, like 2x points, and then you find the change in y in this interval divided by the change in x. Right. So basically what we measure here is delta y divided by delta x. Delta, I mean the difference or the change in the y values divided by the change in the x values. So delta y denotes the change in the y values. Delta x denotes the change in the x values. Another example. So let's say f of x equal to 3 cosine x minus 1. And we want to look at this interval between 0 and pi. So x1, so what is delta x? I mean, you don't need to write x1 and x2. I mean, let's do it in a bit. So delta x basically here is pi. Or maybe just let me write it for clarification. x1 is 0, x2 is pi. So delta x is pi. What is y1? y1 is f of 0. So what is f of 0? x1 is 0, so f of 0. What is f of 0? No. F of 0. 3 times cos 0 minus 2. What is y2? F of pi. Is -4. So that means delta y is -4 minus 2, which is -6. So the average rate of change for this interval, the average rate of change for this interval is delta y divided by delta x, that is equal to -6 over pi. So first, before doing this exercise, can you tell me what is the rate of change for the same function, similar function, but in the interval from 0 to 2 pi? If you replace from 0 to pi to 0 to 2 pi, what do you get? Think about delta y divided by delta x. The change in y divided by the change in x. So the change in x is 2 pi, right? You go from 0 to 2 pi. So the change in x would be 2 pi. What about delta y? What is the change in y values? What is the change in y values? What is f of 0? F of 0 is 2. What is f of 2 pi? 2. There is no change in y. So delta y is, look, if, so delta y here would be, so if x1 is 0 and x2 is 2 pi, so y1 is 2, y2 is 2. So delta y would be 0. So the average rate of change would be 0, right? For this new interval. Is that clear for everyone? If not, please tell me. Angel? No question? Okay. Now, here is an exercise. Suppose that f of x equal to 5x plus 2. Show that the average rate of change in any interval is equal to, is just 5. So take any interval, show that the average rate of change is 5. So that means just have, let's say that you have this interval, x1 equal to a and x2 equal to b. So you have this interval. Compute the average rate of change. So first of all, what is delta x? Right? Delta x is b minus a. Now what is y1? Y1 is 5a plus 2. Y2 is 5b plus 2. So delta y is I don't know why I did this. I shouldn't. I should let you do it. But anyway. What is delta y over delta x? Hmm?
So in this case,
Any number, but not equal, of course. Any two different numbers. Yes, any numbers. So now, can you imagine? I give you this another exercise. Suppose that f of x equal to x squared plus 1. So compute the average rate of change in this interval. Again, a and b. So here, x1 is a, x2 is b. What did you get? B plus A. Very good, Shinjan boy. Not good, Fuzianger. B minus A? At the denominator, you have B minus A. On the numerator, you have B squared minus A squared, right? B squared minus A squared divided by B minus A is A plus B. Right? So delta x is just B minus A. And then f of x1 is A squared plus 1 of x2 is b squared plus 1. So delta y is just b squared plus 1 minus a squared plus 1 is b squared minus a squared. So the average rate of change is okay. Now there is something related to this rate of change, and that is the difference quotient. So what is the difference quotient? The difference quotient is basically so the difference quotient is f of x plus h minus f of x. So you basically look at 2 points. One is x plus h. So maybe I can write like this. So here x1 is x, x2 is x plus h. So y1 is f of x, y2 is f of x plus h. So here the delta y divided by delta x is called the difference quotient. So the difference quotient is quotient is just this, delta y divided by delta x, which is f of x plus h minus f of x divided by x plus h minus x is just h, right? So, but the point here is that x and h could be anything. So there is no specific x and h. These could be any numbers. So any x and any interval h. So for example, can you compute the difference, compute and simplify? So compute and simplify the difference quotient for a f of x equal to x squared, b f of x equal to x cubed, c f of x equal to root x. So this is different. Actually, at this point, I can also teach you some calculus. You're very close. This is basically the beginning of derivative, the derivative of a function. This is just this quotient. But we let h goes to 0. We find the limit when h goes to 0. But that's another topic.
X squared. X1 or X2?
Pardon me? Okay, can you do them? And simplify, and we can suppose here that h is not equal to 0, so you can simplify. So for example, what you get for part A?
I always is the h plus 2x.
H plus 2x, that's right. So it's x plus h plus 2x, right? Now when h goes to 0, what would be the answer?
When h goes to 0.
X plus 2h is just 2x, right? So that means the derivative of x squared is 2x. I mean, it's not a part of this course, but so maybe I can do B. So f of x equal to x cubed. So f of x plus h is x plus h cubed. So it's x cubed plus 3x squared h plus 3xh squared plus h cubed. So f of x plus h minus f of x over h is equal to so you have 3, when you simplify, 3x squared so you get 3x squared plus 3xh plus h squared. Again here, when h goes to 0, the whole thing would be 3x squared when h goes to 0. So that means the derivative of x cubed is 3x squared. Okay. Anyway, but we don't want to compute derivative now. That's enough for us. Let me give you a bonus. Bonus question. Can you find a formula for if f of x equal to x to the power n? Yeah, that's when h goes to 0. But what if, I mean, find a formula for difference quotient. I mean, here we just compute difference quotient, not the derivative. Okay. The difference quotient is f of x plus h minus f of x over h. Okay, guys. Do you have any questions? So please do this exercise, this example ABC. And then if you can, work on this bonus question. And in the afternoon, I'm going to mark your your test. This today. If you can stay, and then I can give back your test after the lunch.